The purpose of this lab was to find an object moving at constant velocity, analyze the data using Tracker, and compare it to a computer model made using VIDLE and Python. The object that I chose to use was my friend on roller skates. The reference scale that I used was his foot size, which was 26 centimeters. On the frame of reference, the positive x-axis points to the right, and the axis origin is at my friend's starting position. As you can see, the graph in the upper right-hand corner created a rather linear graph, as would be expected. In the bottom right-hand corner is the table with the data I would use next to send to Excel. The computer model portion focuses heavily on Newton's second law, which states that final velocity equals the initial velocity plus F net divided by mass times time. Now, because this is constant motion, the F net should equal 0. This makes it so that the entire right half of the equation is 0, making final velocity equal to the initial velocity. As you can see, the initial conditions, the observation start time was 0 seconds, the initial position was 0 meters in all three planes, and the initial velocity was 3.01 meters per second. The average velocity was calculated using V equals position 1 minus position 2 divided by time 1 minus time 2. The average velocity found by this was 3.109 meters per second. The time of last observation was 1.669 seconds. As you can see, here it is in code format. The ball.pos equal to vector 0, 0, 0 in all three planes, and ball.vel equal to vector 3.109 in the x-axis. Here we can reaffirm that fnet equals 0 in the code up at the top, and ball.vel equal ball.vel plus fnet divided by ball.m times delta t is Newton's second law in code format. Ball.pos equals ball.pos plus ball.vel times delta t is the position equation. As you can see, there it is at the bottom in regular writing. And this is what Python came out with. As you can see, the line is relatively linear, and if you remember the graph in Tracker, it looks very similar. And here it is. Here's all of the information in Excel, which I'd use to make the graph. And here's the graph. As you can see, the blue is the predicted, the red is the observed, and it's rather linear, looking very similar. Possible sources of error are that it was difficult to find a perfect average velocity, as the velocity changed very slightly over the course of time. Additionally, getting a slightly angled road made it so that there was a minor acceleration, as you can see where the red graph diverges from the blue line. Furthermore, finding the center of mass in the the Tracker program was a bit difficult because the human body is not symmetrical. As we can see by the results of this experiment, it is clear that Newton's second law holds up under real-world conditions and can be trusted to predict coming positions.